hey, I'd like to do this. And it got upgraded from like a profile piece for kind of immigrants to business piece.
Oh.
And then it went through another round of kind of discussions. But I think that, there is an interest now in the kind of the story about digital sovereignty and digital infrastructure, and Europe really having some challenges. And we play a small part in that story company.
Yeah. What was the title of the article then?
If you Google Jim Dowling Irish Times, you'll find it. I don't know what the title is,
Okay.
but it was a profile piece, I think. So I'm not sure what. I think it was something about building the data for AI systems, so at scale, something like that. Large volumes of data for AI is needed.
Building a platform to allow companies to handle huge amounts of data that goes with AI. Could that be it?
Probably, yeah. It's not a very snappy title,
No,
is it? No,
wasn't.
There it is.
it's very building a platform to allow companies to handle huge. I think it probably couldn't get anything snappier as an explanatory title. Not something you would kind of like just say, oh, I want to read that.
No. Okay, so what was the gist of the article, you would say? What was the core messages you wanted to bring forward?
Yeah, it was kind of partly my story. So how did I go from research to building a company? And it drew an analogy. So my supervisor in Dublin, I did my PhD in Trinity College Dublin, he started a company called AIAW Technologies, and they're really Ireland's first kind of really massive software company, valued at billions at the 99 boom. I think they were right at 5 or 6 billion. So he was the first CTO, and my old research group left en masse. They all left to start this company. Yeah. Company was massively successful. The boom happened. The boom crashed. They were actually the people who invented Corba. If you remember, there's a standard called Corba for distributed computing.
Oh yeah. Before the COM kind of component.
Yeah. So Corba. They were Corba. They were the Corba company globally. And then they got hit by web services, and they got sold, I think, for a few $100 million. But a lot of companies spawned out of that. Yeah. I told the story of Hopsworks, our company, which is very similar. We came from a research lab. We kind of had more of a background in MySQL because the product is built on a fork of an open source database from MySQL. But we were a research lab, and our journey was very similar to AIAW Technologies and similar to, for example, Databricks, who Ali Ghodsi left, where you build very deep tech software in a research environment because business won't necessarily take the high risk in building something that has maybe a lower chance of paying off. And then I think, so the story is partly about that, but then it goes in to talk a lot about digital sovereignty and some of the challenges that we have today and what we're doing as a company. So we're a European AI, a company for building and operating AI systems at scale, and there's not many of us in Europe. No. So it's kind of unique as well. And I think, given that there's a lot of anguish at the moment about the fact that we don't have our own digital infrastructure and AI, we don't have our AI infrastructure either, that, are we going to build it or are we going to continue to rent? I think that's the question.
It's one of my favorite topics as well. So let's get back to that a bit later, perhaps, in the podcast. And I'd love to hear your thoughts how we really can build digital sovereignty in Europe, because I think it's harder than people think. But why is that? And that would be super fun to just talk more about. And I guess we also should be rather thankful for Trump in this case, because it's really boomed, I guess, the interest for actually building sovereignty in Europe. And for your company, it must be in some way positive, right?
I don't like the word thankful, but it's. It's a situation we're in, and I think most companies are here to kind of fulfill needs. So you might have a need for software to help you be more productive or to save costs, and in some cases those needs become weird needs, and that's kind of where we are today.
I guess we all certainly want digital sovereignty for one reason or the other, and anything we can do. And I think also what you're doing and have been doing for your company is certainly something that truly tries to make that happen. So I'm very thankful for that, and I'm very grateful for you coming here again, Jim Dowling. You're also one of my heroes, I think, for your knowledge that you have, but also done a similar journey as I have from academia into more industry use cases is something I really respect. And I think you have so much detailed knowledge about so many questions, and especially this kind of cloud and sovereignty questions, that I'd love to sit down and discuss more about that with you. but also because you actually are releasing a new book, right?
Released. It's done.
Released.
It's out there.
Yeah, congrats on that.
Yeah, thanks. It was a big. Always wanted to write a book. It just never got around to it. It's one of these things, and then eventually did get around to it.
Well, let's go more into the book shortly, but perhaps you can give just a quick background to really who is John. Yeah,
Right. What's the book?
perfect.
Okay.
Yes, I think you can see it.
Now,
Show it now.
Okay. That's the book. It's in O'Reilly. It's published by O'Reilly. It's called Building Machine Learning Systems with a Feature Store, and it goes from batch to real time to LLM agentic systems.
Not the most sexy story, but I think very sexy content. So let's get back to that shortly. But please, who is Jim Dowling?
I mean, I'm a computer scientist. If we talk at the technical level, I come from Ireland originally. I did my undergrad and PhD in Dublin. I've lived in Germany for a couple of years as well. And then I came to Sweden 20 years ago, worked for MySQL for a couple of years.
You worked for MySQL. I didn't know that.
Yeah, and that's kind of the genesis of Hopsworks, because we forked an open source database called NDB Cluster that I'd worked on. And that was the core of our kind of scalable data platform. And when we started the company, we left it. So I went to research. I got actually a Marie Curie Inter-European Scholarship, which was nice. It meant I could get back into research. And I did that at what was called SIX at the time, which I stayed at Rice for many years. And I also then got a position at KTH. I was an associate professor at KTH for, 11, 12 years maybe.
Oh, that's long.
So finished officially last year, but I'm guest lecturing at the moment on course. So I'm still involved.
And without trying to get in too many rabbit holes here, but I have my thoughts about how academia and research works today. And research, of course, can happen in industry as well. But if we just focus on academia, and KTH is a good example, I think. But still, if you look at academia in general, what do you think, perhaps specifically in AI, how the academia works today?
Well, that's a hard question. I mean, AI, like if you look at if you take a step back, like I published an ICML 20 years ago, right? And you look at ICML, you look at some of these conferences now, NeurIPS, I think is the current name.
Yeah.
And, and an ICLR, and they're just insane. These are like, I don't know, it's like Woodstock or something, isn't it? I think, the numbers of people coming. So obviously academia as a whole has taken a very large interest in foundational AI. And I remember I did my PhD in reinforcement learning.
Yeah, me as well.
Which is insane. And there was no interest, So at the time. So now there's huge interest in AI. I think a lot of academia has switched to AI. That's the big thing that I see.
But still, of course, these kind of few selected conferences is super big, of course. But I think, isn't most research, we call it that, not published at all in conferences these days and just put on archive, right?
That's a good point. I mean, things move so insanely fast. Yeah. I think when I talk to my students before, I always talk about impact rather than just number of citations and so on. And impact can come in many forms. Yeah. It could be a library that you build that gets adoption. If you want to get a PhD, you do have to have a research publication or two. But if you want to build a career, impact is important. That career could be in research or it could be in industry.
So what did you choose to go into actually pursuing a PhD at that time?
I think I was intellectually curious, really. I didn't do it for the money. I mean, it was horrendous money. I mean, I lived on, this is a long time ago. I had lived on the breadline, I was intellectually curious. I thought, I wanted to dig deeper. I was interested in computers, and I did my bachelor's. My final project was in AI, but I like distributed systems. I went into distributed systems, and then I did AI in my distributed systems PhD.
Would you do a PhD today if you were at that age?
Oh, that's what the biggest difference is. There's a pyramid in academia, which is. You've got PhDs, and then you've got postdocs, and then you've got full-time academics at the top. And I think when I finished, it was a much narrower pyramid. Now the base of the pyramid is so wide that, and this was actually partly true in my old research group. We had, can you believe this, in our research group in Dublin, we had like 40 PhDs. By the time I was a lecturer at that point. So I was a lecturer in my hometown. I was nice and sorted. But the lecturing job or something. So they all started doing startups during their PhDs.
Oh, during the PhD.
Oh yeah, they're all talking. Oh yeah, and a lot of high value startups came out of that group. A lot.
So okay, so if I phrase the question like this, imagine your kids at some point.
I mean, it'd be hypocritical if I said don't do it, wouldn't it? I mean,
No, it's not. I mean, times are
Yeah.
changing.
will disappear. Will there be new jobs created? It's a great question.
Yeah,
I don't
probably.
know.
But I think this is a question that a lot of people are thinking about, and people are trying to think how they can help their kids,
Yeah.
with good advice. And I can at least see two extremes here, or two alternatives that I don't know which one is the proper one. But one could be that because of AI is happening and it's providing all these kind of very wide breadth of knowledge that you can have. That you can think that humans do something else, and perhaps they give the context because they do the reasoning. Perhaps they have the innovation and power that AI do not have. So what's happening really here is you let AI, especially when it comes more to agentic work, do the more detailed work. And what humans need to do then potentially is to widen up, to become more of a generalist, perhaps understanding the STEM field, so to speak.
So we're steering.
Yes, so we are more in control of them, but then we need to understand the basics, of course, but perhaps be a bit more general. But I heard the other way, and the other extreme could be that companies do not hire like grad or people right out of universities, and it's because that's something that AI can do well. So what they're really looking for is more specialized people that are domain experts in some field. So what you really should do then if you believe in that future, would be that human focus on becoming experts in medical diagnosis or whatever,
a PhD,
and doing a PhD.
I think it's an interesting point. My take is that I still think we're quite early on the journey to AGI. I don't think we're quite there yet. Yeah. And the one thing I would like to do if I was new is learn as much about this as possible. So the one thing I've learned from my years in computers is my sister's an architect, right? And if you're an architect, you have to understand the property of all the materials you're using to build the houses that you're building. Otherwise, if the house collapses, you're in trouble, right? And we have had a term called computer architect, but in my experience, because computer science is based a lot on abstraction, layering on top of layering, and this assumption that you don't need to peel behind that abstraction, you can just work at your layer. It never really holds true, right? So to be really an expert in your field, you need to understand as many of the layers as you can, as far down the stack. And in my company, I said I was at MySQL. We have Mikael Ronström, who was the top guy at MySQL. He's found bugs in CPUs, right? So if you go down the level, the core of our database, there's assembly in there. Yeah. And then you're actually then stepping through debugging on assembler instructions.
And I guess there will be some very few jobs and very specialized people that can.
Yeah, but I think just for intellect, AI is still so early that I think understanding, like if we talk, you mentioned that you provide the context and so on, but like this is something I'm working on quite a lot. The amount of how you provide it, where it comes from, how you process it, how you acquire it, retrieve it, query it, the format, all of this is important. So, if you go in with an education about this, you'll have some skills that will be very valuable for being able to build the next generation AI. So I think I wouldn't be negative on computer science as a field at the moment. I think it's still going to grow because we're becoming more digitalized. But I think a lot of jobs will disappear. But I'm not sure which ones. That's the question. That's the hard question.
But you are still also partly working in academia, right?
No, I said I was guest lecturing KTH. That's what I'm doing at the moment. I have a course I'm guest lecturing on at the moment. The book is the course material. But I'm not employed now.
Okay, so you've gone completely to industry, so to speak, in that aspect, right?
I mean, you can only do it for so many years, that you can try and keep both going, but it's not.
Jan LeCun tried, right? But now we'll see what happens. But,
I mean,
Benji, let's try it. Anyway, okay. And then you've been working now with Hopsworks. I mean, it started off in the KTH years, I guess. How long has Hopsworks been around now?
So we actually left and took in external venture capital money 7 years ago now. 7 years. It's quite a while. I would say time goes fast, but maybe I've aged more in that 7 years. I'm not sure.
Yeah.
But yeah, I mean, it flies along.
And just to give a super quick pitch of what Hopsworks do, how would you phrase the mission of the company?
I mean, if I'm talking to somebody who knows computers and so on, I'll say, hey, it's Databricks on-premise.
I haven't heard that before.
Yeah, well, I mean, because it's easier for people to visualize. So we run on-premise, but just to explain, people don't know what Databricks is. we're a platform for if you want to develop AI applications, if you want to operate AI applications, and then how do you get your data to your AI applications and at scale. So if you're a very large company, let's say you're Ericsson or Saab, or if you're Zalando or Paddy Power, so these are all kind of global brands, then we provide the software that enables them to build AI systems and be more productive in doing so. So get more models built and deployed faster, and get the data from where the data is siloed in these organizations into a central kind of place where then you can actually build AI using all of the enterprise data, not just small parts from different verticals or business units.
I think you phrased it nicely as well, and you called both the development aspect and operations aspect of AI applications, to call it that.
I use the term AI systems more, right? 'Cause the system incorporates the application plus the plumbing and infrastructure underneath it, because it kind of is a system. And an application we think of as at a high level is, it has maybe a user interface and maybe it stores some data in a database. But AI systems actually need a lot more plumbing, right?
Yep.
So they need data to be pulled in from different sources. They need models and so on.
And I'm sure, since we are going to speak about the book shortly, that we'll hear much more about what that really entails. Okay, so that's the majority, I guess, of your work today. And you're the CEO of...
I am CEO, right? Co-founder, yeah.
Co-founder. Cool. Okay, but with that, let's go into the book. And can you perhaps start just a bit about, how did you come up with the idea to get started writing a book, which is super tedious? I've done that partly, but never, not a full book.
This comes from the company. We were kind of category creators in a space called Feature Store.
Yeah.
And the Feature Store it's a data layer for managing data for training and inference in AI systems. So, I originally talked to Manning about doing a book, and then that didn't really work out.
Manning
is a publisher. They're a publisher. They're quite well known in computer science. And then someone on our side said, let's approach O'Reilly. So we talked to O'Reilly, and they said, this is really good. And you have the conference. So we have kind of a natural base. So the conference is about 4,000 people register every year. There's kind of this natural community. And that's attractive to publishers because you have a natural place for people to come in and have interest in the book. So they like the Feature Store element of it.
And this was about 2 years ago or something?
Yeah, project started 2 years ago. And it took about 20 months to write, I guess, which is probably longer than I thought at the beginning.
Yeah.
But I didn't let it take over my life. I mean, one of the things about writing a book is, particularly in AI, it becomes an AI book is not going to be fresh forever. So it needs to be built on some sort of fundamental principles if you want it to last.
And just to continue on that topic, a book, of course, is a big thing, takes a lot of time, and it also gets perhaps a bit outdated in a rather short period of time. But what is the reason that you wanted to really get started writing the book?
I've been advocating a certain way of building AI systems. It started at the university. That I said, okay, this, and I think the course, ID223 at KTH, I think it was the first course globally where students built AI systems. Everyone was just training models, doing inference, but they've been building AI systems for 4 years maybe now. And
Which is such a great thing, by the way. I wish more universities were doing this.
And my bugbear at the time was Kaggle, right? I said, look, Kaggle will not help you build an AI system because any AI system that if it's using Kaggle, you train on the model and then you have some static test data, you make a prediction once and you're finished. An AI system that makes one prediction is not creating a huge amount of value. Maybe it does create some, but most AI systems will continue to make predictions because new data will continue to come in. So the idea at the beginning was that, okay, everyone's going to design a unique AI system. You're going to pick a unique data set and define the prediction problem for that data set, and you're going to build an AI system. And that's actually harder than you think, right? I mean, it's kind of, but what I did in the course, I mean, with the company, I would say originally was, came up with a very simple architecture for decomposing any AI system. So if you have a batch AI system, which makes predictions on a schedule, so if, for example, Spotify Weekly will give you a recommendation of songs once a week, that's a batch AI system. Or if you have a real-time AI system, so imagine you're Zalando and you're browsing the website, it's going to recommend close for you based on what you've just looked at and what you've just done. That's real-time AI. And then you've got, of course, nowadays we have agentic systems which use LLMs, and they may use context data to help make better responses, provide better responses. So for all of these systems, there's a very natural decomposition, which is that you have raw data which comes in, and that data needs to be transformed into input data to the models, both for training and inference, if you're doing training. We call those feature pipelines. So we know in machine learning, a feature is the input to a model. It's typically some measurable quantity. If you're doing large language models, we could call those context pipelines, if you prefer that terminology, but it's still input data into the model. Okay, but there could be
structured
data
or
pipelines.
unstructured. But
it can be structured, unstructured. Yeah. The point is that there's data that is required that is external to your system, and that data needs to be transformed into some format which can be input to the model. And often we do things like, I'll give you an example, feature pipelines, context pipelines. What do? We do compression. We have maybe some raw data out there, and we want to compress it into a signal. We want to do that for features and context. We don't want redundant data coming in. We want to have relevant features or relevant context. We may have features that you're not allowed to use, so maybe gender or something like that. And you have context you're not allowed to use, so you're prohibited from using something or other. So there are a lot of analogies between just taking data and preparing it in such a way that it can be used by models for both training and for inference. So that's the first part of any AI system, is these feature pipelines. And the second part is, if you're training a model, you take the features that were created in the first pipeline, you train a model, and then you save the model. So pipelines, for people who don't know what a pipeline is it's a program which has an interface. It has some data that it brings in, and has an interface as output, a schema that it outputs data as. So typically these pipelines in AI systems have data frames as output, so they'll write out a pandas, a polars, a Spark data frame, or even Flink. You can have data sets which are like data frames. Training pipelines take these data frames in, which will be selections of features, and output models. So they're very well-defined interfaces. And the last pipeline is an inference pipeline. So inference in machine learning means making predictions. So to make a prediction, your input will be the features, the model itself, or one or more models, and then the output are predictions. And this is true whether it's a batch AI system or a real-time or an agent. They're all going to take an input in, and they'll put some output out.
And of course, you have the operations side as well, which you speak a lot about in the book. But yeah, this is at least the AI part, right?
So this was my motivation, that we had this very clear way of decomposing any AI system. And then the students, for example, they could easily talk to each other. You do the feature pipeline, you do the UI and the interface, because the inference will typically have a UI. You want to have some way to consume the predictions. Otherwise, your AI system is not worth much if it's not producing predictions that are useful. So you can decompose work quite easily. And then one of the problems when you decompose things in computer science, when we modularize, is how do we compose them together into a system? So this is where the feature store makes it easy, because there's these natural interfaces. Data frames go in, data frames go out. Models go in, models go out. So
I get that, but just to, I think in some way you can say some things are lacking here. I know you don't think so and have the right view on this, but if people were listening to this and thinking that you're not considering all the necessary framework necessary to do the proper operation of an application as a whole, make sure that it's up and running, make sure that you have the proper latency, make sure that you have security issues or whatnot. Of course, you have a big operations side that requires a lot of work, which is not perhaps AI specific. It's more like general application specific as well, right?
Yeah, the book actually covers that in chapters we call MLOps. So so people use the term MLOps and LLMOps, and I actually didn't use those terms for the chapters, because the way I see it is you can kind of more easily understand the operational requirements as being offline testing requirements. So when you're developing, you'd like to run tests. So there might be unit tests or integration tests. Model bias tests, feature pipeline tests, inference pipeline tests. And then when you have an operational system, you have monitoring, observability, are key properties that you want to have in any AI system. So that's kind of so I don't use the term MLOps. I split it up into the runtime or operational aspects, and then the offline aspects of testing before you deploy. And of course, that's key to everything. But I think like in terms of how we build AI systems, a lot of people have a challenge in just getting to a working small AI system, and that's the goal of this book in particular, is how do I get to a working AI system as fast as possible with as simple a mental model as possible, which is where the feature pipelines, training pipelines, inference pipelines comes in. I give you a mental model. You can now decompose the problem of building your AI system into these three main components. And then from there, you'll get a minimal viable, I call this term minimal viable prediction service. So you probably know the term minimal viable product.
Yeah.
But AI systems are prediction services. So I call it a minimal viable prediction service. And from there, you then, of course, add testing and operational concerns and layer those on over time.
Cool. So if I understand correctly, I mean, that was the reason that you took on the big investment in time and effort that you have to spend to write a book, to give your kind of mental model in how to decompose these kind of systems and bring that piece of knowledge, right?
Yeah, if you read the intro of the book, it says, this is the book I want for my course, ID223, which is true as well.
Which you use it for the course
Yeah, it's
as well.
used for the course now.
Yeah, I mean, cool. And then if other people are interested in writing a book as well, perhaps you can give some kind of advice. How do you approach this? I mean, you're a famous person, you have a name, and that means that you can speak to publishers like O'Reilly and they will get interested, so to speak. But how do you go about, finding a publisher, get started to at least have, some way to get started with the work of writing a book?
Yeah, I can tell you, like for me, I wrote quite a lot in the space, and particularly for feature stores, I did a lot of content, wrote a lot of blog posts, gave a lot of talks, and I think, and then I organized this conference, the Feature Store Summit Conference, which is relatively high profile in that small space. Yeah. I think, one of the issues with a lot of there are different publishers. So there are some publishers where it's a bit easier to get in, and there are some that are a little bit harder. And I think many publishers don't invest massively in marketing. It's easier if you can have somebody who can market your book because they have a social media profile. So it saves them, going out and marketing your book as such. So I think, if you want to just write a book and get out as fast as possible, there are publishers who, if you have good content and it's in a relevant space, will listen to you straight off the bat, like packed. I know a guy, Paul Azustin, he's from Romania, and he's quite big on LinkedIn now, but he wasn't when he wrote this book, and he got it in because it was about writing LLMs and agents. They said, fine, great, let's publish it, and it was a very successful book because he was first out. So you don't have to have like that kind of deep background in research or as an influencer if you have good content and you're very timely with it. But I mean, in general, I think I've been writing for most of my adult life. So for me, writing is kind of just a natural skill that I developed through academia and so on. If you're not as comfortable with writing, then you should take it as a big project and kind of dedicate. I didn't dedicate. I kind of fitted my life around writing the book rather than fitted my life around writing the book, the other way around. So
keep the work-life balance, so to speak.
Well, I live in Sweden. I try to. I wouldn't say, my wife wouldn't maybe agree with me on this, but,
If I phrase a question like this, is there anything in terms of how you wrote the book that you would do differently if you were to write another book? Or a follow-up for this?
So I know a guy, professor in the Netherlands, Martin van Steen, and he wrote a book in distributed systems, which is used by most courses around the world. It's not AI, but he basically told me, I wrote my book and it took me 1,327 hours. I'm like, what are you talking about? And he said, well, I had, booked in my calendar these 3 hours every day, and I count the number of days it took, and it took. If I could do it in a structured way, that would be the way I would do it. Just assign time and say, right, 2 hours every day, and have that discipline of sitting down and cranking it out. That would be the best way of writing a book.
Cool. I will certainly have a look at this, and I think a lot of people need to learn so much more about builder proper prediction services, we call it that, not just building a model or a prototype and believing that's the end goal in itself, which so many people seems to do. Right. I would like to just go into one of the terms or the terminology about feature stores, because I think that is something that has partly confused me a bit in the past, and I think could confuse other people. And there is a lot of similar terms, of course. could have data pipelines, you call it feature pipelines and feature stores. Could you just try to give us your view of what do these terms really mean?
Yeah, I think so. The feature store as a concept, it wasn't me personally. So Uber were the first people to write about their data platform to support their AI systems, and they gave the term feature store to it. So that's where the term came from.
And this is 10 years ago?
Or this is 2017.
Okay.
End of 2017. So their platform, and people don't write if-then rules for it anymore. We train models to try, and people don't write if-then rules for it anymore. We train models to try and match those drivers and passengers up. So the platform has low latency real-time data you need access to, but also needs large volumes of historical data. So, when I worked at MySQL 25 years ago, we had relational databases and that was it. But since then, we've had the emergence of data warehouses and what we call columnar data stores. So that's Databricks, Snowflake, what we call the lakehouse now. So in Uber's case, they stored large volumes of columnar data for the training data to train models with, and then the real-time data in what we call a row-oriented database, so a low latency database. Because if you go to Snowflake and say, hey, I want to get this information about how many passengers this driver's picked up in the last week, it'll take about a second to get it back. And at Zalando we have some 2 millisecond requirements. It's kind of very low latency. So the data platform you need to support operational AI is complex. It needs this columnar store for large volumes of historical data and a row-oriented store for real-time data. And we actually had this in our platform when we were when we started and left KDH. Our goal was to build a scalable data science platform. And then we knew about Uber's Michelangelo platform. We said, well, that's the kind of platform we need to provide, because Michelangelo was not a public platform. Yep. So I think, when you're a developer, I can give you 2 different databases. Let me give you an example from this week, a very topical one. Okay. This week, Cloudflare was down for 18 hours. Most of the internet was down. The reason it was down is because they built their own feature store. I'll try and explain what I'm saying, right? Yeah. So they have a machine learning model that's deployed to all of these edge nodes, and it takes as input features. We said already features are the input to the models. So some of these features are pre-computed. So there may be global things around activity globally. I'm not sure what the features are, they didn't tell us. But it's pieces of information that they use as input to the models. And then when the models are deployed to the edge, they'll get local data from the edge as well. And they'll combine both of those to make predictions about things like DOS attacks and so on. So what they have is they have a big database called ClickHouse, which is a columnar store. And so they're storing these features in ClickHouse. And what you have then again, as you said, is you'll have, they might use the term data pipelines. So we're computing features in our data pipelines, we're storing them in ClickHouse, and then we need to materialize those features, meaning copy them from ClickHouse somewhere. So often materializing features you do when you're creating training data, you say, I've got all my features here and I want to get last week's training data. So you go to the feature store, it'll give you the training data for the last week, maybe as files or maybe as data frames, and then you go and train your model. So what a feature store does is there's certain things that are hard to do when you're materializing data from many different tables. So firstly, ClickHouse is a tabular data store. It's not just a columnar data store, it stores data in tables. Now, what they did was they wrote their own feature store. So they had a query which would read the data from this table and store it as features for the model to pick up. Right. And that query was buggy. I think it might have been dependent on some permission or access control that got changed. I'm not sure if it was because of a configuration change they made or whether it was an upgrade in ClickHouse. But basically it wasn't tested, right? It was just something they kind of hacked together. And it resulted in duplicate data in the feature file. So we actually had a debate internally this week. We have different Lakehouse file formats. We have one called Apache Hoodie. It prevents duplicate rows. And we also support Delta Lake, which is another Lakehouse file format, and it doesn't prevent duplicate rows. It has a primary key, but it doesn't enforce uniqueness. Hoodie does because an index for it. So we talked about this internally and saying, well, should we not do this? We should not, because we've seen this problem happen before. We saw it happen before at customers. And this change needs to happen in the Lakehouse file format, and we haven't done it. And It's not a proposal yet. So we say, if you don't want to prevent duplicate rows, just use hoodie. So, a feature store will ensure these guarantees that things like when you materialize feature data, that you don't have duplicate rows and so on. And, the ClickHouse database didn't do anything. I mean, they wrote some code themselves. And then when this code got distributed, it caused all their systems to crash. So the feature stores provide a bunch of guarantees that a normal data warehouse wouldn't provide. And they also provide real-time data. So I'll give you a quick example of one. Yeah. In the book, we have weather data and we have air quality data in two different tables. I want to build a machine learning model to predict air quality. So I have air quality observations, and there's sensors here in this part of town. And you can find the timestamp of the observation. And then I can get the weather from a different source, and I can put it in different tables. Right. Now, the timestamps will never line up exactly. It's time series data. So you have a problem of, if I get this air quality observation, what was the weather at exactly that time? So in database terminology, it's something called an as-of join. It's a temporal join, and many databases don't support it. Actually, most don't support it. So if you use Databricks, there's no support. And we built in support for that type of query. So you get what we call point-in-time correct training data. It doesn't have stale feature data. It doesn't have future data leakage. And it's important when you're training correct models.
So as of is more like you have some flexibility in the exact timing so you can still match up things? Or?
Well, I mean, the rule is the following. If I have an observation of air quality at this point in time, I take the closest weather observation, but before it, not future value.
Right. Okay.
And maybe it's not so important in air quality prediction. It could be a little bit before or after. Yeah. But if you're doing credit card fraud prediction, you don't really want to know, be based on a future usage of your card, because then you're going to predict on something that happens in the future, which is not what we want to do in machine learning.
Okay, so it's adding. I mean, it's simply that's harder than people think to build high quality feature stores, we call it that. So if you do that
that's one aspect. We'll get into another one, right? So when I want to ingest data, let's say take the credit card fraud example, it's in the book as well. So we have credit card transactions arriving, and typically they'll arrive on an event platform like Kafka or Kinesis or somewhere like that. What we'd like to do is we'd like to be able to understand activity levels on your credit card, because machine learning models will use those as features to predict things like a chain attack. Somebody manages to find your card or steal it, and they go run around town and they start using it at lots of small payments.
Been around that.
All right, not good.
Not doing it, but being victim, yes.
Sure, and of course we have geographic tax where your card is used some infeasibly far away location within a short period of time. These are kind of what we call features that help predict fraud. So you have all this data coming in, and you'd like to do it in real time. So what you can do is you can say, okay, I'm going to compute these features, and we can let's call them counts over windows of time, right? Or sums of money spent over windows of time. And those features we want to have as input to the model, and we want them to be what we say as fresh as possible. We don't want them to be half an hour old. We want them to be 2 hours old or 3 hours old. We want to compute them as you use your credit card to basically know exactly what's happened. So feature stores provide the infrastructure to do that computation and to serve those features at low latency.
So you keep being all the time the freshest, so to speak, and this kind of logic that you need. I
think the most famous one is TikTok, right? So have you heard the term TikTok digital crack? No. So it's so addictive. I think Andrew Karpathy said that. He called it digital crack because it's so the recommendation algorithm is so good and so reactive. For many people, it's like it feeds dopamine. Like basically, when you click in TikTok or swipe or share or like, every event you do, every action you take is an event that gets sent to a very large Kafka cluster, and then those events are processed by an even larger Flink cluster with tens of thousands of servers.
All right, are you using Flink in TikTok?
Yeah. It's Flink, and then
Alibaba, didn't they?
They did. They bought the company Ververica behind Flink from Berlin. That was a classic. We need to get into that, but that was Europe losing. So it just geostrategically, a little side discussion briefly, but at the time Alibaba couldn't build that technology. So, but China have now built on Flink. All of Alibaba and Huawei and WeChat
ByteDance.
and ByteDance are running on Flink, so the Americans can't shut them down. So,
Interesting.
but it's European technology.
Yeah.
Anyway.
we should be proud of that.
And it's from KTH originally.
Yeah,
The original streaming engine was done at Rice and actually Rice and KTH. So
Flink is cool stuff.
Paris Carboni and Eula and Safaridi.
Awesome. Okay, so
Back to the point, TikTok, within a second or two of you taking an action, it will make very good predictions about what, if you're getting bored or if you want to get more interested, and that's all powered by this feature store technology.
Cool. Good. And I think that could be a good reason to dig more into the book to truly understand what the feature store is, because I don't think it is a really well-known concept, right? And I know you also are speaking a bit about more agentic workflows. And of course, it's a super popular term these days. Everyone is speaking about that. And I think a lot of people are abusing the term agents and agentic workflows in extreme these days. But still, perhaps you can get a bit more into how feature stores are related a bit more to agentic workflows.
Yeah, sure. So agents, as we know, basically they're think of it as being, you have an LLM has an interface. It takes in a request and returns a response. But whenever you want to an agent to perform some task, it could be a chatbot. That's what everyone's familiar with. That's the typical task we have. But we see Klarna here in Stockholm have agents to help them respond to customer support requests. So if we take that Klarna example rather than the chatbot example, we say, okay, somebody goes to Klarna and says, there's a problem. You're charging me too much for this thing I paid for on order, and I missed my payment. But so for the agent to answer that question, the LLM doesn't know anything about your private payments. So there's a lot of private data that Klarna have that the agent doesn't know about. Some of that data will be policy documents and PDFs, and many people know about things like RAG. So you would say, okay, let's chunk the policy documents about payments and late payments and cancellation policies and terms of payment. Some of the data will not be in vector databases and probably will never be there. Like your orders, the transactions you've taken, your history, that data is stored in operational databases. A lot of it is in data warehouses. It's in tabular data systems, and that data will not, I don't think, end up in probabilistic search engines, which is what vector databases are. So, and then so the LLM has some private data it can't access. Some of that private data will be kind of static, but some of it will be very, very recent. So maybe I just performed an action. I went, oh no, that was terrible, and I called Klarna within 30 seconds or a minute. This is where we get into feature stores. Now we're into the TikTok style case. So when you take actions, that data then gets fed into your system. Maybe it arrives at a Kafka cluster and spreads out to the data warehouse and the feature store. When you ask, and this is what's covered in the book, right? Many people think of agents as kind of like LLMs, where you have the interface to an agent is you send it a string and it gives you a response. That's kind of the assumption, right? You've got string in, string out, because that's what an LLM has. LLM is tokens, to be more specific. But agents can actually have an interface, a schema, an API. So if I have an application which is a Klarna help desk, you're probably logged in, right? So you probably have a user identity. You may have a problem, an ID for the transaction. You may have an order number that you made that you can quote, or you don't even need to provide it because the application knows that you clicked on it. You say, I'm going to complain about this. So it picks up the order ID, it knows your ID, it knows the transaction ID. So the agent can be sent these IDs along with your query. And then at the back end, the feature store pulls out the data related to those IDs and injects it into the context window as context. So that's the role of feature stores at the moment for agents. They can provide real-time context to agentic workflows.
Good. Okay, so we can mix the private data, something coming from a Kafka stream and whatnot, and then also fetch data from feature stores and combine that into a recent and relevant context to the agent.
Yeah, I mean, like just for the listeners, again, if you take a little step back, I mean, I have the second lab in my course this week is about fine-tuning LLMs, and people kind of wonder, how do fine-tuning relate to context and so on? I mean, LLMs have a cutoff date and they have certain data. And to incorporate data outside of that training data set, private data, let's call it, you can fine-tune. You can collect your training data, fine-tune the LLM, and add something like LoRa adapter to enable it to answer questions on that private data. But again, like, there's going to be a cutoff time for the fine-tuning. So everything that arrives after that, it will have to be context. And then the context is going to be, the LLM can use it to perform something called in-context learning.
Yeah, I hate that term, by the way, but okay.
But it's covered in the book. Like, so in-context learning is the next branch of machine learning.
Okay, since you brought it up, let's discuss it a bit more. Because the reason I hate it is, I agree with what people are trying to say, and it's a well-used term, of course, but it's for me, at least, learning and adaptation is two rather well-defined terms, and learning means in some way that you actually change the behavior in a way that can be reused at some later point. You actually build experience in some way. And if you just have in-context learning, you're not really changing the parameters or changing anything that can be reused afterwards, right?
I mean, that's one definition of learning. Another definition of learning would be that I can take supervised learning. I can say, here's an example of, and this is what I think I covered. You have an example of two different types of stone. We have one that doesn't exist called Lumerite, another one called Zeronite. These stones don't exist, and they have features or properties. They have a shape, a size, and so on. So I can provide in the prompt examples of these two different stones, and I can do a binary classification machine learning challenge, which is, here are examples. Here's a test set, an example of stone you've never seen. Can you classify it as Zerorite or Lumerite? And they work. Now, so it's not like classical machine learning where we have a training phase and then we have this trained model that keeps the learnt patterns and then can use them to make predictions.
Isn't that just understanding the data that you provided in a few short sentences? Right?
Yeah, you can call it that as well. But I mean, it depends on what you define as learning, right? Yeah. So if we agree that classification tasks involve learning, because what we're saying is there may be a nonlinear relationship between the features, that it's not just a case of statistical kind of property that you're trying to infer.
But learning is something that you learn. I mean, it is literally the term that you use, that you add some piece of knowledge to your system, right? Yes. Or your brain, and so, it doesn't really happen.
So this is where we get back to context, right? So this is what's interesting. So the learning process for agents is not training models. It's actually collecting relevant context, and it's collecting lots of information to make it available as context, and then being able to retrieve relevant data. So
but if I were to defend the term here, the way I would defend it and say it can have a proper meaning is that if you differentiate the context from a single prompt to like a multiple or a set or a session that you have, you can certainly have reuse of a certain prompt in a longer session by having a set of intermediate kind of predictions happening that you are later reusing. So in that meaning, in the end of the session, you can do stuff that you couldn't do in the beginning.
Yes.
So that at least in some way, I would say, argue positively for the term.
I mean, I think, look, that's the trend in large language models. That has been the trend in the last couple of years. So, the notion, that's why we have reasoning models, right? So reasoning large language models, that we take an input string and we say, okay, I'm not going to try and answer the whole question. I'll try and maybe do some entity extraction from it, so entity recognition from this. So, and then I'll ask questions about the entities, and I'll try and build up some context data, if we use the term. Yeah. So that later on it'll actually put in the full question and have much more context information available with which to answer the question. And I think that's the general trend that we're seeing in agentic architectures, that you try and decompose whatever the queries are into components in which you can basically bring in more context. And if you want to call it learning, or if you want to call it
context engineering,
you can call it context engineering. Yeah,
it's kind of a nice term, I think.
I think, because for me, context engineering, one of the students this week said, oh, was that RAG? And I said, oh, you're so 2023. And none of them actually knew the term context engineering. I was surprised. They weren't keeping up to date on what's happening.
Another, I'm getting into terminology here, but it's just because you are such a knowledgeable person, and I think it's interesting to try to just understand this properly. So we can say that, a string in, a string out from an LLM is one thing. But what would you say the difference between a traditional LLM and an agent is? I mean, a lot of people have so many different questions or definitions of this, but I think it would be interesting to just hear your thoughts about this.
I think an agent is there to solve a task, so a well-defined task. So if you take the most popular agents, let's say, we'll bring up Lovable again, it's a coding agent. Yeah. And I do have actually a specific philosophy in this because we're building our own coding agents. We call it Brewer in Hopsworks. And it's that, so coding agents are there's two types of users. There's the users who want to write code and help them be more productive. And I've heard people use the term, instead of using it vibe coding, they call it vibe engineering. I don't know whether that sticks or not, but the point is the LLM will help generate code and you understand the code and you can fix the code. So this is, proper software engineers, and they're getting a lot of use out of it. In our company, we have a lot of people using it, and it's very productive. Then you have the Lovable people, and a friend of mine showed me his website. They did it in Lovable in Dublin on Monday. Jason, call out. So, and he was really proud of it, and he was really happy. The guy can't write a line of JavaScript, has no idea what it is, no intention to learn it either. But the reason why it works for him is because Lovable has a very natural intermediate representation of the output. It's the web page. You type in the commands and it updates the web page. You can see, as you progress, you can see this intermediate representation of the website that you can iteratively improve. You don't care what's actually compiled to the JavaScript.
The backend is or whatnot.
So we're doing this for pipelines, for feature pipelines, training pipelines, and agents themselves. That for people who don't want to necessarily use Cursor or Claude Code, but would like to be able to write these AI systems because they know I know what my features are, I know roughly what model I'd like to use, and I know how do I like to make predictions, that you can still, as a domain expert, generate code. So we have an intermediate representation that the domain experts can iterate on. So they'll need to have some understanding of what they're doing, right? They'll have to know this is my data. This is what bad data looks like. These are transformations I'd like to make.
But getting back to the LLM versus agent, because at least in my view, because even in my PhD long while back, I spoke about agent-oriented development. So for me, the term agent is rather important. But still,
I think it's been taken from us. So for me, when I heard it, I'm like, come on, I'm in reinforcement learning. An agent,
exactly.
An agent has a goal, and it's going to achieve that goal through.
But even the classical reinforcement learning definition is usually using the terms agents, of course, but then also saying, of course, understand the environment, but also to take some action that influence the environment.
Yes.
And
you have a time horizon as well.
Yeah. And if you take a classical LLM, let's say the only thing it can really do is just an API. You put some string in and you get the string out. I mean, then, if you have a really shallow definition of an environment and say that is the only environment, then perhaps you can say it's an agent, but I think it's too loose.
No, but that's not what they do, right? So at least from my understanding, what an agent does is your query comes in, right? And like I said, sometimes there might be an intermediate step. I talked to some people at booking.com, what they do in their agent, and they do entity extraction, right, from the query to get extra context.
Named entity recognition, or
sorry,
was it named entity recognition?
Yeah, named entity recognition would be kind of so NER. But what the agent does, maybe there's these processing steps like that, pre-processing steps, but then it goes into what's called the agentic loop. And the agentic loop is...
But that's a different thing. Okay, so
that's what an agent is. I mean, that's what agents are.
But that's not what all people use it for.
So but if you're working in agentic programming now, the agentic loop is what it is.
Yes.
There's nothing else.
But that was a completely different thing, because then I think if you have a loop, at least, one, I think, definition that I like, at least, is that the agent should have at least a choice of what action to take. If it is a loop, it certainly has a choice to get out of the loop or continue the loop.
Yes.
So at least make it, if you just have a single input to an LLM, and
I think it is evolving, right? So you probably have heard of these protocols, right? There's MCP, Model Context Protocol, which is the agent will access tools. They'll get a description of the tools and they'll be able to invoke them. There's another one called A2A protocol that Google have to call other agents. But there's another one called AGUI, which is growing massively. I don't know if you've heard of it.
No, not that all.
Okay, so it's AG-UI. We're adding it to our agent as well. It's taking off quite a lot, but it's basically a way of getting feedback from users. So it's assuming this agent has a user interface.
Yeah.
And one of the things about agents is they are kind of asynchronous, because they don't just give you one answer at the end. They stream the answer out, but they also may need to get input from you and say, hey, can you clarify this? I need some future direction or some direction, because I can't accomplish this task without your feedback as to what I should do next. So I think that's becoming part of kind of naturally, because like you said, the agent will need to maybe clarify and go back to you and talk to you. And I think that's becoming part of it as well.
Yeah, but even if if you take the reasoning loop and say that it will do some kind of chain of thought thinking, and then say to an agent, and I think even that in that case is too broad of a definition of an agent.
For me, the chain of thought reasoning in the book I covered, it's not part of the agentic loop in my worldview. Chain of thought reasoning is just the way to say, I'm going to take the query and get more context from it by asking questions about parts of the query, or asking meta questions about the query and the inputs, and then summarizing that and maybe following some paths down, and then getting all this context together, and then say, here's the query, here's the context, give me a better answer. So that the agent it is in fact doing planning. That's the thing. That the agent, you're basically saying, here's my query, here are all the available tools, and you ask the agent, what should I do? The agent is doing planning in the classical planning sense.
One way, a metaphor that I usually use here, and it will be fun to hear if you think it's useful or not, is actually self-driving cars. Yeah. And it's kind of easy to understand what an action is there. It's no question. Yes. I mean, it's so easy to understand. They have perception, basically needing to have knowledge management to understand all the cameras and whatnot. Then they need to do some planning, how to get to the end destination. But even with a plan, they can't do anything unless they take an action. And an action in that case is very simple. You accelerate, brake, or turn left and right. Yeah. It's very, very simplistic. But then it certainly lives in an environment, a physical environment in this case, not a digital environment, but a physical environment. And it's clear that it influenced the environment by taking a very concrete action. So, I mean, it's super clear. It's no question that the self-driving car is an agent, right?
Yeah. And I'll decompose that a little bit further, right? Because how do you evaluate an action? Because it's easy to evaluate a self-driving car, right? We know we don't want it to crash. We have a way of measuring whether this agent works. So in the book I covered, there's a new area called evals. If you heard the term evals. Evals are considered a data set that you, with, let's say it's a query that goes in, an expected response that goes out. And you pass in the query, you get the response, and you need to somehow evaluate if that was what you expected your agent to do. But you can decompose agent evals into two sets. One are objective evals, where you can actually measure the output. So the agent took a task, maybe in the digital world, and then you can validate in the digital world, did it write to my feature group? Right. Did that write succeed? And is the data there that expected to be there? But then we have, unfortunately, subjective evals.
No, sure.
And that's where agents like Klarna, your customer rep, was it a nice answer? Did you feel good? Did it satisfy you? And that's where people look at LLMs as judges and humans to kind of to really bootstrap them.
And just to end off the topic.
So that in that case, agents aren't. I don't think they're as well defined as when we worked on them before.
No. But we know it's supposed to at least do something more than just knowledge management tasks, I hope. Or
I'm going to throw something interesting at you. I think about, because I know you get deep into all this stuff, right? And
I'm just trying to find a good definition.
Okay, but let me throw you something crazy at you, right? Yeah. Because Jan LeCun has gone to do his world model thing, right? And I was thinking about it, and I was going, hang on. Because I always say I was shocked that LLMs were as successful as they were, and it's because being able to predict the next token, you need to have a model of the world to do that. That's that's what some people have said. But so I was thinking about it, and I was saying, if an agent actually can use tools and it has context information, which you can get from anywhere in the world. that information, as long as it comes from any source, be it the physical or digital world, and it comes in as context, the agent has the LLM has a world model. So there is that interaction between the physical world or the world of actions, and it's on the terms of the LLM's model, which is the model of language. Yeah. So if you can translate things from the physical world into the world of language, then the agents can be active in the physical world. That's kind of my take on it.
I heard Anthropic speak about this, and I think they defined it. I'm paraphrasing them now because I don't recall exactly what they said, but for one, it was that it should be a choice in some way, and I think they had like 3 categories of different agents. So
they have workflows, agentic loop, and
and also Andrew Ng, he said it well. It's basically a spectrum of how autonomous it is. I mean, you have super low agent, it's basically just an LLM, and then you have super autonomous agent that are taking a lot of actions, without even interacting with a human. And then there's a big spectrum, but I think there should be a lower bound here.
I mean, I don't to be unkind to Anton, but I met him about 14, 15 months ago before Lovable took off, and we were having an argument about a discussion about how you generate code, and he was like, prompts are the way, great prompts and static prompts. And then I saw an article from them in August, I think, where they said, well, they're going over to agents.
Yeah.
So it's that underlying discussion. You're going from,
but they usually agent. I think we had him here on the podcast as well. So he explained the loop that you do. They're doing an advanced set of agents. I would even call it in Lovable. So it's no question that is agents to me. What I'm thinking is more like if you write. I actually did this recently myself, just for the podcast to get some planning help. So I have a planner agent. Yeah. But the only thing he's doing is basically going out, doing some research on LinkedIn, pulling that together, summarizing the person, looking at what he has written before, and then trying to come up with a good set of questions and a plan for that. But I've hard coded what it should do. Mm-hmm. I've told it to go and look in these places, and then do this until something is finished, and then continue with that. Do that. So I hard coded 2 set of tasks to take to end up at the goal. I wouldn't really be comfortable calling that an agent because I've told it exactly what steps to take. Do you see what I mean?
I do, of course. This is like the notion of priors versus what you can, how much knowledge are you building into the thing? Yeah. And at the moment, we have to build in a huge amount of knowledge. And that's kind of why I said I'm not so worried about all the jobs being lost, because we do have to encode a huge amount of knowledge in them. There's only small, very focused tasks that they can perform at the moment. Yeah. And giving them a wide open task, like find out about this person on the internet, I don't see that.
That's actually a great topic. And perhaps we can get back to that, Goran, later as well, and speak more about, where are we really today when it comes to more agentic capabilities, so to speak. That would be fun when you get to more philosophical questions.
It's time for AI News, brought to you by AIAW Podcast.
Cool. Yes. Yes, so we usually take a small break in the middle of the podcast to just speak about our favorite news topics that we heard about, and there's been a couple of them. But let's start with you, Jim. Do you have any favorite topics that you'd like to share?
I do. There was a large conference or summit, I think you'll call it, in Berlin 2 days ago, and it was called the European Digital Sovereignty Conference. And there was a nice picture of Macron, the French president, with the CEO of Mistral, and then the CEO of SAP with the German Bundeschancellor. Right. And they're kind of lifting up. So, we're a European company, we're based in Europe, and I think a lot of people are worried about the direction in which, our friends are going in the States, and we're worried about a democratic future. And the one thing that we can see is that, we're renting our digital infrastructure, and that's okay. I mean, would the Americans invited in the British to build the railroads in 1800s? I don't think so. But the Americans have built our digital railroads, and the news basically is about take control. And, the Americans have complained for a long time we didn't take control for defense, and we're trying to do that. And I think the same is going to happen for digital infra. In my space, enterprise computing, I think every large company I know has left Europe to go to the States, and it's kind of tragic. And I'm hoping that will change. I think this is a starting point for some change, and that first you have to identify the problem and agree that it's a problem. And Europe always has that as a challenge before we can actually decide what to do about it.
Okay, so this was the summit of European digital sovereignty, right?
Yeah, I think there was some Swedish representatives from the government, and there was a bunch of other, prime ministers. It was a big one, right?
Did they come to some conclusion, or what was the highlight? Did they all agree that we have this big problem with European sovereignty, or what?
Yeah,
did they
I
come
mean,
up with?
you might have read in the news there were some agreements that like regulation needs to be pared back a bit, so the EU AI Act the adoption of it will slow down.
That's a big news in itself, by the way, right?
It is, and I think one of the unfortunate things about, if you're a business, right, let's say like our company, and you go all in on the European AI Act, and you spend a lot of money being the first to be compliant, and then it's not enforced, because that's what happened with GDPR. GDPR was introduced and it wasn't enforced for a few years. It's enforced now, but it took a few years. Then it's very hard for you to plan, So I think it's better to be honest and say, okay, we know that people won't meet the regulations for a period of time. Let's delay them, but at least whenever they come up with a clear timeline, please keep to it and then enforce the regulations, because otherwise it's kind of crazy,
No, but let me not go into the rabbit hole of GDPR and the AI Act, but these kind of recent changes, if I'm not mistaken, I think one of the GDPR changes was to allow personal data for training purposes, for AI training purposes, in not all of it, but it was a relaxation, so to speak, of the requirements, at least. To use it for training purposes.
What the AI Act defines levels of data. So you
risk
have
levels.
Yeah, the highest risk level you're not allowed to use to train models with. I think it's reasonable, to be honest, right? Who wants a model that's going to be biased by gender or race or things like that? And I think there's a lot of reasonable ideas behind it.
Yes.
To be honest, like, in our space, move fast and break things has worked, right? Ignore all regulations if you're Uber and come in and just run it. And that model, which is the Peter Thiel model of technology, I think we'd be better off maybe without it, and if I know it's fast moving and so on, but my take is that, like, I don't want models. Like, we have a huge problem with the voice of the chatbots today. You ask one chatbot, I think in the book I gave an example, if I ask an American trained chatbot about Gaza, I'll get a very different answer to a Chinese trained chatbot about Gaza. It's the same thing, but they have different worldviews about it. And
perhaps you can rephrase it like, it's beneficial to be agile, so to speak, for tech development, but I wish we could be as agile for regulatory purposes as well, right?
Yeah, I mean, it's not easy. Like, honestly, it's if I knew the answer, I'd be out there.
But I think one was it was some relaxation about how you can use personal data for training.
Yeah.
It was also some reduction for the cookie rules, the horrible cookie pop-ups that we get all the time.
Yes.
So I think that's really, really good that we're seeing that. But then it was a set of relaxations for the AI Act. I don't really recall exactly. But it was something for smaller.
Yeah, I think that was one of the
etc.
outcomes. Another outcome was, I think they're trying to promote European technology, right? So there were rules about. There is an interesting new proposal on the table, which is how do we define sovereignty levels? So the Commission has a proposal in the works, which is saying, okay, if you can take European people's data and transfer it out of the EU, then you're not the highest sovereignty class. And that will cover any companies covered by the US Cloud Act, which would be Google, Microsoft, and Azure. And, I hear all the arguments about, regulation will slow us down and so on, but in Europe, we have no cloud company. It's kind of tragic, right? And the Chinese have great cloud companies, and the Chinese didn't open themselves up. They regulated themselves that way. So, look, I mean, I think we're in a kind of crisis situation where, we want to be able to enforce our own laws. We want to decide these are European laws, these are our values, and we're currently not doing it. There are European laws on the table that are being shelved and changed because we don't control our own digital infrastructure. And for me, that's not okay.
Okay, so great with that conference. Great that they're speaking about the problem. Great that they're actually taking actions as well to try to improve on the situation and perhaps get better preconditions for actually having some sovereignty.
I will add the last point to it. I think the who's got away scot-free are large European companies. They're all hiding behind and blaming the Commission and so on. But let's be honest. If Ericsson or SAP or one of these large European companies had started European Cloud, we'd have rode in behind them. We all would have. I'm pretty sure they would be large and successful. But they're all too conservative, and I think that's so. What is one of the most promising clouds is the little cloud.
Yeah.
Like that's crazy, you know.
Well, I just so want to get more into this topic. I actually add that as a topic later. How we could be potentially building European cloud, but perhaps later if we get time for it. Cool. Any other news that you'd like to share? Or?
Well, we all saw Jan LeCun left his job. I mean. I think we were talking about that earlier. It's very interesting, but not clear what he'll do.
No, and we spoke about it in the last week's podcast as well a bit. But now it was at least some clarity on what he should do, right?
I mean, he's building a company, so he's raising capital for the company. He's talked about the Japa World model, but I think it's going to be a long way off whatever he's doing. It's probably on a longer time horizon.
Yeah, I wish I had the article here now, but I think it was some company that he actually has started with for some time back, but not really perhaps worked that much with, that he's going to continue on.
The other news this morning was that NVIDIA reported good results, so
the
AI bubble won't burst for a little bit longer.
Yeah, the stock market has really moved in the last couple of days.
I think there's a lot of nerves and
it has
people down.
Well,
obviously
if
not
you
that
look,
much. So if you look at the numbers, it's a Meta actually that is dropping the most. The rest of it is pretty stable. Google is going up after the Gemini.
Yes.
Nvidia is pretty solid. So they went up after the announcement.
But it was a general tech reduction in the last couple of days.
But Apple is now orienting themselves with Google. So if you look at their stocks, it's completely steady. So Amazon is completely steady. So the only one that is very volatile are just two, right? So you have Tesla and you have what is called Meta.
I never understood Tesla being up that high.
If you look at,
I can't understand their valuation.
So you bring up so many interesting topics. I'm biting my tongue all the time to not go into it. But anyway, the general stock market, if you just look at the index, actually moved quite a lot in the last couple of days compared to at least a couple of last months. Anyway, Jan LeCun, yes. And just to recap, perhaps, then he's been the hero of, I think you phrased it very well, actually, before the podcast. And do you recall, his new boss kind of thing?
Oh, I mean, I think he got moved. They had a reorg, and his boss was Alexander Wang, who founded a company called Scale.ai. They were acquired by Meta for several billion. But they did data labeling. So if your new boss for your AI is a next data labeler, it's kind of. That's not an AI kind of.
No, but
task.
As you said, he's a Turing winner. He's one of the three.
He's been great at predicting, at seeing. He's been hammered a lot because of LLMs, and he kind of talked a lot about, the fact that they're regressive, autoregressive, and actually that was one of the tasks for the students in their course. I said they're doing air quality prediction, which is autoregressive because they're using predicting tomorrow. So,
but it's not like it's against LLMs or against transform. He's the biggest force broker for self-supervised learning.
That was actually the key thing. You say, well, he didn't do LLMs, but he was the number. The cake. You remember the cake where self-supervised learning has been the key technology for training large language models,
and he doesn't want to get rid of that, and transformers he loves and wants to continue with and has done so. Anyway, such an interesting topic. I wish the best for Jan LeCun, even though it's been a bit of not the best of times, so to speak, for him, I think, in recent months.
No.
Cool. Quick update. Otherwise, I think Gemini 3 was released this week as well. And
it was quite good. Yeah, the scores look good. Yeah, and trained on TPUs, not on GPUs, not NVIDIA GPUs. So that was interesting.
Yeah, it's leading the leaderboards now, taking over LM Arena, etc. And it's been a large number of releases now in just a couple of weeks, right?
On the hardware, I was at a conference, a Ray conference in SF 2 weeks ago, and there were actually talks on Huawei's accelerator. You know, Huawei have a competitor to
Huawei.
NVIDIA.
Oh, yeah. Huawei.
And I was kind of shocked, you know.
Yeah.
This is the first time I actually seen it in the real world in live.
Yeah.
So it might be a thing in a few years' time. Who knows?
Yeah, cool. No, but just to give some kind of summary of the recent releases here, we had, of course, GPT 5.1 in last week or something. I think it was, right? It was kind of an incremental
What's new
small.
in it? I don't.
No, nothing. I don't think. The way that Sam Altman phrased that was that we don't care about leaderboards anymore. We just do it because we want to have a more appreciated style of language or something. I think if he were to be leading the leaderboards, he would be bragging about that all and every day, right?
You know it.
So I think that was just bullshit and a big excuse. And they have not been leading in the leaderboards for a long time. They were in the top of LM Arena for the normal 5.0 for some time, but it's not been that. And normally over all of 2025, it's been other frontier labs, I would say. Gemini primarily, but also Grok has come up, and of course Claude in coding and a lot of these kind of tasks. So I think this is just, and now we just saw Gemini 3 released, and of course it took over from all the others. Claude and the Opus one has been leading a lot, even in text-based, kind of normal text-based tasks. But now Gemini took that back as well.
But do you not think like that you know, Ilya Sutskever says, right, we've hoovered up all the data. They're kind of tending to kind of converge. And
No, but I don't think so, actually.
no, you don't think so?
I think it depends on how you measure them. If you just measure them on knowledge management tasks, being able to take a large piece of data that you train on and just recall features from it, then they're really good, and that will be hard to surpass. But I think actually they're surprisingly bad in reasoning capabilities right now, like Arc AGI kind of tasks, which are still really bad. And even to humans, they are still bad in that. And I would even argue, and perhaps you don't agree with this, but I would even argue also in action capabilities that are really bad today. And we can get back into that later. But I think that is something that we will see a lot of improvements in coming years.
One thing I do notice is they're using a lot of context. Like they tell me things like, because you work in feature stores. And I'm like, how do you know I work in feature stores? So they are storing a lot of information about us and feeding it as context. So that we'll notice that over time.
Do you have given all the models we're seeing now, the Gemini, the Claudes, the Grok 4.1 came recently, I think Elon is saying. Yeah. It wasn't a super big improvement. Elon said that Grok 5 will come this year. We'll see, and it will be AGI. Let's not even comment that, perhaps.
No.
And then we have the Chinese models as well. What do you see now in 2026? Who do you think will start to rise to the top there, if you were to guess?
I mean, there's two types of models. There's the frontier ones, and then there's the open source ones.
Yeah.
And I guess my interest is more on the gap between them, which has kind of been that gap has been closing over time. And I think in the long run, I do think Sutskever's right, and that it will tend with the current technology we have. I don't see it's growing to the sky. I don't see us reaching AGI on the current path in the near term.
Yeah, agreed.
So, yeah, I think the interesting story will be convergence of open source models or open weight models, I should say, rather, and frontier. I mean, it looks like Google are really taking this seriously, and Google are extremely competent engineering culture, and I think they'll probably keep improving relatively. That's the only thing I can see.
So Grok, Anthropic, and
we use Anthropic and OpenAI actually, and for coding agents. But maybe we'll have a look at Gemini. I don't know.
Yeah, Gemini is getting really good in coding as well. Okay, interesting times as usual, and a lot of stuff is happening in the world of AI. But getting back a bit to perhaps Hopsworks a bit more, and also going a bit more philosophical and thinking. We had the old time of, you brought up like Spotify's Discover Weekly kind of batch systems, and then we have Zalando and other systems doing, or King, for example, is doing a lot of real-time workflows. Yeah. What would you say the challenges are in moving perhaps a bit more towards these kind of real-time systems and perhaps even agentic workflows, and how is like Hopsworks trying to address that?
Yeah, I mean, we took a bet early that people would move more from batch to real time. So we built out the infrastructure for helping companies build real time. So it's a little bit of a change. So batch is this notion that you take data on a schedule maybe once every hour and you copy the data over. If you take Spotify Weekly, it's going to pull up all the data from the last week. It's a big Spark job. If it's a little bit late, or the Spark job has failed, or some workers fail, and you have to restart them, or it does that automatically, but it's not the end of the world. So batch is kind of operationally not as challenging. That's why most companies will start with batch. But if you want to add real value, like TikTok is the most valuable AI system in the world today. Still, it creates the most differentiation and the most value, and it is the real-time aspect of the prediction of the recommendations that it makes that differentiates it. And building that is hard. So I think a few years ago companies were more inclined to go this way, but when LLMs arrived, budgets just swung right over to LLMs and everyone went all in LLMs. So I think the real-time AI space has not grown as fast as expected. We had some competitors in the space. So when we started in the feature store space, I think there were 4 companies in America raised 20 million, and another raised 165. They're all gone. None of them are left because the space hasn't grown as fast as anticipated, and there's only space for a few winners. Like, it's one of those things. So for us, it's been it's not been the hockey stick kind of from day one. It's been building a database company. And I don't know if you heard the cliche, it takes 10 years to build a mature database. We're at year 7, so we're getting there in terms of the data platform. Yeah.
Okay, so for one, perhaps you said real time is most valuable. I guess there are a lot of examples for that, but I guess there could still be use cases where batch could be useful.
Most use cases in enterprise are batch. Like the vast majority, things like email classification, marketing campaigns, churn prediction. A lot of these kind of, grunt work in that data science teams produce at their batch. I think what's changed actually are agents, because most agents aren't batch. I think, there are batch. I would argue coding agents are kind of batch. They don't have real time means that you have some expected response within a bounded amount of time. Like, so if I have an interactive agent and it builds on a competitor platform and it takes 2 minutes or 5 minutes to respond, to adapt to what you just did, you won't perceive that as being intelligent, right? So, I mean, at a very basic level, an agent that is interactive and will respond to actions you're taking, it needs to do that in a second or two. Otherwise, humans won't perceive it as being intelligent. And that's kind of the tech we're building for that. And it's not,
But it depends on the task, right? I mean, if you're playing chess, or if you're even a
course.
coding agent, if it takes a minute, I can.
But a coding agent's not an interactive agent, right? So there's going to be like your agent that goes out to LinkedIn and profiles that's a batch agent, right? So it's going to be both, of course. But I think a larger fraction of agents will be interactive. That's my expectation. I might be wrong, but I think a larger fraction of agents than the AI systems we had before, machine learning systems.
So interactive in like a second or sub-second kind of time frame, or?
Well, that's what we provide. We provide infra to get you to the sub-second level. And now some people might say, well, I don't need sub-second, I need 10, 20 seconds. And that's fine. So there's going to be a spectrum of use cases. I mean, companies who buy our platform, they do because they have many use cases. They don't just build one AI system, they build many use cases on them.
Why is streaming or these kind of real-time use cases harder than batch?
Oh, that's all right. Yeah, I mean, the operational aspect I touched on, right? So if your batch pipeline fails, you can go grab a coffee, come back, fix it, and it's ready for the next time it runs. Operational, the warning flags go flying and things aren't working. Let's quick fix it, right? So you have to have high availability built in typically. Like, so components fail, they have to keep on running. You have if you have spikes in traffic, you have to handle them. In batch case, data can pile up fast or slow, won't matter. You're only going to process a bounded amount. But in streaming, often the data is coming from external systems and you don't have control over those. So you can get spikes in load and so on, and you need to handle all of those. So there's a lot of operational work in it. Yeah.
Yeah. I remember, the back old like Hadoop days and writing the first batch jobs and comparing like a single processor kind of algorithm and needing to parallelize that into a batch mode. It was a big thing and really hard to do. And you had to rethink, how they even wrote the the algorithm to make it work. And I guess in some way doing a streaming version of that is also a big step where you...
And that was like maybe 10, 12 years ago, right?
Yeah.
It felt like it was huge. It wasn't that long ago,
No,
right?
yeah.
In the greater scheme of things, it's not that long ago.
Yeah.
I mean, streaming is part of it, right? Because real time, a lot of people who write applications, what happens is all the actions, the applications, you just kind of stream them out to an event bus like Kafka or something like that, and that's where the data comes in. But your application can also, you can enter text and data, so it can come in through requests. So you can have the query string, of course, as an input parameter. So real time is a combination of both. Data that comes in when you have a request for a task to execute, and also then this kind of background activity level data. So data can come in many different ways, and you kind of need to have this central view of the data so that you can take that data, whether it's context or features for machine learning, and then process it in such a way that it's going to be, help you with your query, give you a better answer. And then you've got to think of the operational aspects, like am I generating too many tokens, or is it feasible to compute this? Is it taking too long to compute this or to retrieve this? So there's a ton of different things that come into play that you can just kind of ignore in the batch case.
I remember playing a lot with the Flink founders as well back in the days, and how they came from from normal kind of traditional database world in the beginning, and then they rewrote or reused some of the ideas, but still came up with a really novel way to do streaming, which Spark didn't do because they tried to have batch and then add streaming on top.
Batching, and it's still a problem. Like, so if Zalando's biggest, the big Databricks' biggest customer in Europe is Zalando, and Databricks say everything has to be Spark or SQL. Yeah. And they can't do real time. So you can't do the click and then the data gets through. Firstly, you get to the Spark microbatching, and then you get to their lakehouse first kind of world. So the data gets right to the lakehouse and then sync to the databases. So it's minutes. Yeah. And we have a different kind of philosophy where the data is real time first and then goes to the lakehouse after, or in parallel.
So what is the tech stack that Hopsworks is mainly building on, so to speak, if you can share something about that?
Yeah, sure. I mean, a huge amount of the platform is open source. So the core kind of technology is a database we built called RonDB, named after the inventor of the database, Mikael Ronström. The database came originally, it's a Stockholm story. It was originally built at Ericsson, and then MySQL bought it over where I started working. And it's been open source, and we forked it, and now we're the largest contributor to that cool. NDB cluster platform.
So what's specific about RonDB, if you were to just quickly...
Yeah, I mean, it's an in-memory distributed database. You can have data on disk, but primarily it gives you very fast access, low latency access to data. So if you're building a real-time AI system, you might have a budget of 50 milliseconds or 60 milliseconds or 100 milliseconds for doing something, taking an action. And that budget has to be split between getting the data, making the predictions, processing the data. So you want to keep that budget for the database as low as possible. And if you're going to DynamoDB, it's 20 milliseconds or 10, 15 milliseconds, and we can get down to 2 milliseconds. So you're going, great, I can spend more time doing AI instead of just going to the database. That's what makes it unique, and it's kind of high availability. So you can have lots of servers and they can crash. Some can crash and it keeps running.
Any other major component you like to highlight? So,
well, with the feature store is kind of the I guess what we're best known for, which is effectively you can think of it as being a way of managing the data that comes in and the transformations of the data coming in and storing it for training and inference. So we do have a lakehouse as well as RonDB. So RonDB is the fast serving of the featured data, but we build on open standards. So
is
open
it Delta Lake? Or
Delta Lake is one of the OTF, open table format standards we support. We support Apache Hoodie. Iceberg will come soon. And we have built in Kafka as well to ingest the data. And then we provide compute. So it all runs on Kubernetes. So you can run jobs in Hopsworks. Like you can run Python, you can run Spark, you can run Ray. What we also do is we'll manage GPUs, because if you have GPUs for compute, Ericsson, for example, have a massive cluster with, you know, tons of GPUs. Can't say the number, but it's lots.
Yeah.
And they use Hopsworks to for training and inference, and running things like Ray and so on, at scale. So, and
Kubernetes, do you use the vanilla open source, or do you use some more?
well, we don't use Kubernetes in a sense. We just run on any Kubernetes distro that's there.
Okay.
You know, so it's kind of, when we started Hopsworks, we ran on virtual machines because we didn't think Kubernetes it wasn't mature enough to run databases on. And it took us a while to get there. Like, we should have gone earlier, I should say, because the great advantage of moving to Kubernetes is that we started out doing a managed platform in the cloud where you would deploy it into the customer's account, and we'd have a control plane and we could manage that. And we still do that, like, for example, with Zalando. But now that runs on Kubernetes. And we can take the same whole software platform, and anywhere Kubernetes runs, we can run. So if you're in an air-gapped environment off the grid, Hopsworks still works there. You know, so this is great for running in European clouds or running on private data centers. We can, you know, we have some customers, some government and law enforcement customers that we run on, and they're air-gapped.
And you use Ray as well. Can you just elaborate a bit more?
Yeah, so we provide compute in the platform, but this is where we're a bit different from, let's say, Databricks or Snowflake. We don't force you to use our compute. So if you want to run compute outside Hopsworks in Flink or Spark or anything, that's fine. But we do provide compute. And I would say in the cloud, a lot of customers would bring their own compute. They're already running EMR or Databricks or something like that, and so we just keep using it. But if you're in an on-prem environment or in a European cloud, maybe you don't have all those compute frameworks available to you, then they use Hopsworks compute. So we can run Spark or Python or Ray jobs, the primary. So Python means anything, right? So it could be polars or pandas, or, you know, it could be training with Torch or, you know, all these kind of things. So
cool. So you support a number of open source. So I guess that's a big important point here. You called yourself like the on-prem version of Databricks in some way, right? Or
yeah, I mean, to make it easier for people to understand, because it's like it really, you know, we provide analytics, and we so it's not just the you know, we have the lake house for storing large volumes of data. We actually have a query engine as well coming in now called Trino, and Superset for doing analytics, right? So yeah, so then like, because the trend in our space has been Databricks have done incredibly well in the last 2 years because they unify analytics and AI, and you buy one platform and you get your analytics and AI in that stack, and this is very attractive to a lot of enterprises, because a lot of you'll know probably from your experience, integration is a huge amount of work. You have different platforms and you have to talk to multiple vendors. So we're following the same strategy where we started with real-time AI, and we have then, you know, batch and LLMs, and we've just added now this analytics capability as well.
Nice.
So we're, you know, effectively saying, hey, you know, we're providing similar capabilities to Databricks, but with a different, I guess philosophically what we're most different is we're open compute, that you use bring your own compute, that's fine. And if you have 130 billion valuation, you don't want open compute.
How much of, if you go a bit beyond perhaps the normal kind of tech stack and the jobs and the compute and the storing you provide and the feature stores, etc., but think more about, you know, the full life cycle of MLOps or DevOps, or whatever you prefer to call it. I mean, things like perhaps even data governance, or having data catalogs in some way, or even becoming compliant in some way, or you know, all these kind of things, and monitoring, of course, and security. Anything of these kind of aspects that you're also helping out with in some way?
Yeah, of course. I mean, if you're kind of providing a platform, you have to cover all these bases. You know, enterprises. The hard thing about selling to enterprises is you build something great, and then they say, "Well, I would buy it, but you're missing this." And of course, security is a table stakes, and to be honest, governance is table stakes as well. Like if you're not doing audit logs, if you're not doing access control and all that kind of stuff, you're just not going to be there. You know, monitoring is built into the platform as well. Again, a lot of it is open source components and so on. But I think the days of you buying from 6 vendors, 6 different products and pulling them together are pretty much coming to an end.
But I guess also that's what the big top like cloud providers help with a lot, which do provide a lot of value. But if you don't have that, that's surprisingly hard to do by yourself.
It's extremely hard. I mean, I think, the amount of teams we've met who spent years building infra instead of building AI systems is insane.
Because I think that's so. I mean, at least
we don't want our customers to build infra. We want them to build pipelines. We want to build AI systems
applications.
No, of course, application.
Yeah.
So the pipelines are there to feed the apps, but without the app, you have no value. You're not creating any value. Yeah. So companies should focus on, getting their data, preparing the data, training their models, making their predictions, and integrating with applications. And then, we just provide the infra to connect that together. And whatever you're building, you should build with open source tools, not with proprietary techs and compute, because what you're going to be locked in.
And it's stuff like the Cloudflare incident will probably happen to a lot of companies then. No, but I think this is so important. I think so many people are missing this. And I think also it's a bit, perhaps not the most sexy topic to speak about, even for you, I think, in Hopsworks sometimes. And I hear so many people saying, but we have a great working demo here. You can see it's training and it's doing some inference and it seems to have some KPI that works. And then missing, like, it's 100 or 10x more work required to actually put this in production properly. And to just do that, it is easier, of course, if you run on the top cloud providers. It is. And that kind of value that they do provide, I think people do not really understand. Yeah. And if you want to not be super dependent on them, we need something else, right? And,
I think there's a general, like if you look at we come from a database background, and there's not two. The way we have this thing where we converge, and there's 2 standards. There's Android or Apple, right? Yeah. There's not 2 databases. There's like 50 of them. Yeah. There's 100. You go to DB rankings, you'll see actually 300-400. So, I think at least for building and operating AI systems, it would be a tragedy if we have 2 or 3. I think we really need diversity. And one of the most interesting trends I see at the moment is these data processing engines. There's been this Cambrian explosion in data processing engines. So if you go back 25 years ago, when I worked at MySQL 20 years ago, everything was a relational database. And along came big data, and there was key value stores. If you remember DynamoDB,
of course,
people were excited. And then we had Hadoop, and then we had Neo4j graph database, and we had
still do Neo4j.
Yeah, but the point here is that we had all these specialized databases like a JSON store, Mongo, and a document store, and Elastic. They all became viable databases when data volumes increased, and everyone didn't want to do relational databases. So we see the same trend in data processing engines. Everyone has done Spark, or not everyone, but a lot of people have done Spark. A lot of people know SQL. SQL is always going to be there, but SQL isn't always the best tool for the task. So we see frameworks like Pandas has been forever, but Polars is growing a lot. Really great, interesting data framework. DuckDB has grown massively. I was at a DuckDB conference 2 weeks ago in SF. We work, an ex-KTH person actually has a startup called Feldera. And Feldera does something called incremental stream processing. It's really interesting tech. So let me give you an example of a problem. Okay. So imagine you're doing credit card, we'll take credit card fraud again. So we have a lot of activity in this region here in Stockholm, and we want to maintain statistics about number of bad transactions or anomalous transactions. So every time an event arrives, why Flink is really good is because it'll recompute aggregations and so on as that event arrives and output it. It's real time. But the compute is proportional to the size of the number of events. So the computational complexity of recomputing that aggregation depends on how big that bucket is, how many events are in it. Right. When you get to 1 million events and there's tens of thousands of events right per second, it doesn't work. That's a kind of dirty secret of Flink. Okay. So these guys have rewritten this as an incremental compute engine. It's called incremental view maintenance, and the computational complexity of recomputing the aggregates is proportional to the amount of data. It's order one, the number of data.
Okay.
So it scales, and it's really beautiful. So that's a new compute engine that's out there. It's open source as well.
What's the name of it? You said?
FELDERA. It's SQL. Feldera. I mean, it takes SQL and compiles it into Rust, so it's ultimately a Rust engine. But I mean, this and there's another one called Materialize. Frank McSharry. They're trying to compete in that space. So we see tons of these engines. Daft, you might have heard as well. I don't know. I can keep going on all day. So I suspect that there is a role for a lot of these engines in different specialized workloads. Ray, we mentioned, and that's kind of the future of data processing will be in.
So it's good that's happening, but it's also kind of hard for companies that want to orient themselves in the space, right? So then we need to,
I mean, the answer is use Spark and SQL for everything, but like, when you're doing specialized workloads, if your name is Zalando, you're not using Spark, right? You're using Flink.
I think you mentioned, I haven't really read through all the book, but I saw in the digital version at least that you also spoke a bit about function calling for LLMs.
That was kind of going at the beginning. So without even getting into agents, because a lot of people jump in straight into agents and MCP and say there's tools and so on, but MCP is built on function calling, right? So I think in chapter 3 we kind of just went in and said, okay, how do I get external data? In this case, it was the air quality prediction example and a description of it, and how to get that and insert it, inject it into my prompt. And function calling is the kind of the. So your LLM will return and say, here's the parameters for the function, and then the client can call it and get the result and insert it back into the prompt.
And get it better with JSON strictness and structured output, right? So
I mean, nowadays people take it for granted that all LLMs will return JSON in the structured context, but it wasn't the case maybe a year ago or so. So
it's moving quickly.
So
okay, cool. I would like to move to a more difficult to answer question, perhaps, but still, we touched upon European sovereignty a number of times. But if I give a bit of a longer intro here, I would love to hear your thoughts about how can we really build European, perhaps not cloud providers that are better than the American or the Chinese, but at least are sufficiently good so we can rely on them. Besides Hopsworks, and in my view, one way to phrase this in a negative sense, if I start there, is to say that if we take all the big ones, both American and Chinese, I would say, they have been successful with their super big, cloud service because they worked 10 years with internal infrastructure and built up that kind of infrastructure for their own purposes and then turn it into a public cloud to a cloud where they can simply externalize the functionality in a very not very but in an easy way. But it is a ton of work. It's like tens of years and thousands of people that's worked with it. And now Google have probably 5 exact copies of just how to do key value stores that they built internally, and then they chose some of them to just put it in a public cloud. And who in Europe could ever do that? I mean, if you take a company like Spotify, I mean, then they went to Google early on, and used them. Zalando can't do it. SAP, no way, I don't think. I mean, do we have any such company, or is it really required to have a big company that built up their internal infra if we're going to have a competitive cloud service in Europe, you think?
So I don't agree with the assumption that you have to first I'll give you the counterexample. So the proof by negation, if you will. Perfect. Oracle. So,
okay.
I mean, Oracle have now, I mean, I laughed at Oracle. I think it's only 5 years old, right? It was horrendous at the beginning. I mean, it was horrendous. Yeah. Now I know Eric at Mo something, but we had. I'll be brutally honest. We had bean counters from Handels running the company. They were never going to have a vision to.
It's 3 times the market cap.
Yeah, it's 3 times now. But I mean, if you go back 2 years ago, it wasn't the case, or a few years ago.
Yeah, but there are some big companies.
In 2020, they were around the same market cap, like roughly. But then that's there are companies, but I think look, there is the capital on the one side, but I had a meeting this morning at Evrock, and if you know Evrock,
Of course. I know them well.
So Evrock have I really like their vision, and their vision is not to repackage OpenStack. I won't go into the details, but a lot of cloud providers in Europe are like, okay, there's an open
You mean
source
the standard OpenStack, like
so
which
OpenStack, as you know, is kind of an open source kind of cloud infra, if you will.
or a standard for it.
Standard, but a lot of the cloud providers in Europe just kind of repackage OpenStack and kind of put it out
And
there.
it is a bad one, if I may say so. But still, okay.
Yeah, I mean, it's like LibreOffice, right?
Yes,
like
yes.
in a sense, like you look,
That's a
it's
good
clunky and kind of terrible.
Yeah.
But the thing is, it gets better over years, but it's still not Amazon quality, right? It's not. And I think they kind of understood this. Everyone said, okay, we're going to build a lot of this core stuff ourselves, and I think that's the right way to do it.
Yeah. Certainly.
And they've raised some capital, but I think they do need help. So what I'd love to see, and it'd be crazy, right? But and this came out a bit. Europe is Germany's going to spend 200 billion on defense. How did the internet start?
Yeah. I'm with you on this.
Why don't they say we need a German cloud for it's going to cost us 50 billion, and we're going to build a German cloud for our defense and go and build it. I would say that we're partnered with quite a lot of clouds around Europe, not just Evrock or friends. OVH in France. We actually moved. We have a freemium version of Hopsworks that we ran in AWS, and we moved it to OVH because we went from spending around $15,000 a month to around $5,000.
Oh, interesting.
And you know what? It's better performance. And do you know why it's better performance? And this is the other thing about clouds that people don't talk about. The public clouds are not very good for some things. So the disks that you get on the virtual machines are disgracefully poor performance compared to what you can buy here in El Giganten or somewhere. So I can buy an NVMe disk here for 1,500 crowns. It'll give me, 5-6 gigabytes per second, and the best I can get in Amazon is 1 gigabyte. And when you're a platform like Hopsworks, that makes a huge difference. But OVH give us good disks.
But it also, you can argue the opposite. If you go to Google Cloud, you can get the top of the line like hardware.
You can't get the NVMe disks there either.
Take AI hardware, for example.
Oh, AI hardware is very good, but the disks is an anomaly, right? And it's because my take is that it's because S3 is the cash cow that keeps everything locked in, and if you provide low cost, high performance disks, data services that are not S3 can kind of. So I think there's some things can be done a lot better than there. Because I'm not as negative as you. I think technically, what is a cloud computing platform? It's two things. It's software, and then it's infra. Infra being the buildings and the capital. If you get the software and you get software that's good enough, then it's just a case of scaling up the infra and scaling up the investment.
And I did want to start a negative point, so don't say that I am that negative personally. I'm just saying
you are. I'm just.
But it is. I'm trying to find a negative reason, and if I were to argue against myself, then I think reason that we do have a chance to build a European cloud is that we don't need the extreme number of services that, for example, Amazon provides. Most companies need a fraction of that, and they have spent so much time building things that very few selected companies may need. So if we just could have the core essence of the services, actually like 1,000th of the amount of work they have spent on that would be necessary to have something that is sufficiently good.
I can tell you, like my investors listen to this, but we burnt a lot of money doing this, right? So we started out by building a cloud managed version of Hopsworks where the control plane was in AWS. And we had all the cloud native services for spinning up the virtual machines, and we're using, the DNS service. We're using the internet gateways. We're using Secure, and in the end, we're like, let's go to Kubernetes. So a huge overlap in terms of the cloud native services that you use to build applications are available in Kubernetes. So the advantage of building in Kubernetes is you can go to any cloud. You can just move it and migrate it. And I think that's helpful for building a competitive. If you have a simple managed Kubernetes platform, a lot of workloads will be able to migrate it to a European cloud. And I think a lot of people are developing applications now and systems, particularly if you take data platforms, so databases and data processing platforms, They all run in
Well, 200 billion, not bad, but it's completely different kind of structure for who gets what.
Oh yeah.
So it's not like 3 major companies that's driving everything that have experience in doing these kind of things. It's spread out to the huge number of small institutions, and the success rate of that, I think, is very low.
It's the wrong way.
Right.
In this case, I'm sorry to say, but you have to pick the winners.
Yeah.
The Chinese picked the winners, and it worked for them, right?
Yeah.
So yeah.
But I like the defense part. We will have need to build for some purposes so much infrastructure, and it needs to be sovereign, and it needs to have quality. And perhaps, as internet got started, so could perhaps the cloud business get started. Who knows? Cool. Let's see, the time is flying away here a bit, and I would like to just think a bit more about, we have Hopsworks today. You have the book that speaks a bit about how we can prepare for some of the agentic workflows in the future. But what do you think? If you were to not think 20 years, but perhaps 3 to 5 years, what do you think will happen in terms of how agentic works or other AI workflows will change?
Well, that's a big question. I think you can make a lot of money if you get the right answer on this, couldn't you?
We're getting more philosophical, so it's
But
okay to
no, it's
speculate.
great. It's great to speculate. I think the world of work will change. There's no doubt about it. I don't like to quote. I mean, a lot of people quote Andrej Karpathy. Said it's the decade of agents, not the year of agents.
Right.
I do think he's right in that. There's this cliche in machine learning which says that 90% of the work is data. It's data preparation. It's getting the data to where it should be, and agents will not be about LLM leaderboards. It'll be about the grunt work of context engineering that we talked about earlier. It'll be, agents will be performing tasks that we want to automate to make easier, so that maybe a lot of people lose jobs because those tasks will be automated. But those tasks are knowledge tasks, and they'll need knowledge that is not just encoded in LLMs, but knowledge from the world around them. So private data, real-time data, and that context data will need to be translated, or let's call it transformed, into a format that can be fed into the agent. So that's a lot of work. We talked about stream processing and how long it's taken it to sort of mature. It's still not like mass market yet, but it takes 10 years. So I think it's going to take that time. A lot of things will need to be digitized if they want to be used by agents. They're not everything is digitized at the moment. So I think it's going to be quite a long journey. It's hard to say what will be next. I think coding has been one of the first things to be, let's call it, upended by agents. I think my near-term prediction is data analysts.
Yeah.
I don't think it's, you might say it's controversial, but I know from experience of, writing these SQL queries to generate these dashboards. At the moment, the way it works is that an executive in a large company might say, well, we need more information on sales in this particular area, and we need to know about disruptions. And they'll create a request, which will become a ticket, and the data analyst will get the ticket, and they'll get a sprint. They'll do out the dashboard, and it'll come back. 3 weeks later, the executive will have their dashboard to help them make a decision. That will go from 3 weeks down to 3 minutes.
You quoted what I just said myself, and some other people in Global Connect just very recently. So I love that, and just to phrase it the way that I usually speak about it is, I think AI for coding, as you say, is coming a long way. I think it's more or less almost like a window to the future in some sense.
Yeah.
We can see what AI can do with agentic abilities for coding today, and it cannot really do it for a lot of other workflows we have in the organizations today, but it will happen. So we can see a bit how that is affecting us and impacting us, and that will be a big change in coming 3 to 5 years, I think. And I think agentic analytics, if we call it that's what we usually call it, is certainly such a case. We're not having the same capabilities for AI in analytics as for coding, but we're starting to see it. And what Snowflakes and others are doing, and also Databricks, of course, with their
And
kind
Hopsworks.
and Hopsworks. Okay, cool. Is really doing exactly what you say. You bring a workflow that normally took like 3 weeks down to 3 minutes.
Yes.
And the same for coding then. come even further.
I think what the first task that will be automated have in common is the context information needed to them is kind of like almost like closed. So if you think about coding, you have your source code tree, right? And then you have some libraries and some API docs. So the context is readily available and it's there. If we think about data analysts in SQL, again, so one of the problems, for example, to get technical is SQL warehouses and SQL databases, they have columns and they have tables, but they don't have metadata to describe columns and tables. And we've had that in the feature store, so that made it a bit easier for us. So what we could do is we could take a table that's in Snowflake, mount it into Hopsworks, and then the LLM would read some of the data and propose descriptions of the columns and the table. And LLMs, once they have that metadata, they can make that. So if the context data is completely available for a task, I think agents will pretty quickly come into, I mean, you can see in legal, for example, if you take law, a lot of the documentation is available, legal documents are available. Do you need context information beyond that? Probably not. So that's another area will be upended quickly.
But I still think, which I think you also said, we still need to make sure the data is properly available then, and with a sufficient, not perfect quality, but sufficient quality to make the agent work. And we've actually done a number of things like that at work. And if you do get it right, then it seems to be magic on top of it, what the agent can do. But if you don't do that, it's still a lot of work to prepare the data properly, right?
Yeah.
But there is a big promise there, I think.
Yeah.
And just to elaborate on another thing, and thinking more like geopolitically perhaps, or at least more from a company point of view, we can see that some companies, especially the big tech giants, of course, are adopting to these technologies very, very rapidly.
Yeah.
And they have done so for many, many years, but are going to continue to be very, very fast, probably, to adapt also to these new agentic abilities.
Yeah.
But perhaps not so for a lot of other companies. And one term we use a lot of here in the podcast is the AI divide, playing on the digital divide. But now speaking about that some companies we can already see the most valuable companies in the world. If you look at the top 10, they're all these kind of AI-enabled companies, I would say. And then we have the long tail of other companies, and especially in Europe.
Yes.
Right? And then the question could be in coming 3 to 5 years, either we are pessimistic and saying the big tech giants and the one that are working really, really fast are just going to accelerate even faster. And the other one is going to continue to be slow, and the gap will increase. That would be a negative scenario.
Yeah.
But we can also see companies that are perhaps not adopting at all, and they will probably die out.
Yeah.
Right. So there will be, of course, a lot of tech progress in coming 3 to 5 years. We're continuing to see that. But adoption, what really will happen with adoption? And will the AI divide continue?
I think it will. Yeah. I mean, if we go back, 25 years ago when digital photography started coming, Fuji were a massive company, and I had both. I had the early digital camera, I had the physical one. You could see it was coming. I mean, you started using a digital camera. It was just so easy. And you knew that this would die out, but it still took people years to kind of figure it out. Yeah. And the same with going to smartphones. We saw that trend. You saw it. And we can see the same with AI. It's pretty clear that if you're not adopting these technologies to build intelligent systems, and your competitors are, you can be in big trouble. So it will be a big change for a lot of industries. And I think, it's going to be, here's a big one, journalism.
Yeah.
I mean, journalism, there's so few jobs there now. Yeah. That was a big industry 20, 30 years ago. Yeah. But the internet upended it. So I think this is going to be a lot of industries that are going to be upended now.
I want to find a positive twist on this. So let me try to also do that and see if you agree with that. And when it comes to American versus European possibilities here in 3 to 5 years. And then the negative spin, of course, is the AI divide will continue. Yeah. But if we take the average company in America compared to average company in Europe, I think if we actually get European companies to adopt, not compete with the tech giant, but adopt to this type of technology fast, which is something that we in Sweden and Europe have actually been rather good at when it comes to technical, adoption or digital adoption. Mm-hmm. If we just could do that, then I think Europe could actually be faster in adoption for average companies than American ones.
I think there's a huge opportunity here for Europe as well, right?
Yeah.
Now, my working thesis at the moment is that LLMs and open source LLMs will effectively commoditize intelligence. That's maybe you consider a strong point, but I think LLMs, we understand the technology, the transformer technology, and if that is the case, then the largest LLM labs around the world that are training these models mightn't have the competitive advantage that we think they will have. And you see this on a lot of the leaderboards, right? So a lot of the leaderboards that are improved are, hey, it's now an agent, it's using context. So just this notion that I get context information and I have a query that I want to ask the LLM, and I'm able to augment that query with the relevant context information, and now suddenly it performs much better. That is the technology we need to develop, and we can do that in Europe.
Right.
But to do it, we need to go data first. You need to have your data shop in order. So you need to be digitalized. So if you're not digitalized as a company, that's the first thing you need to do. You need to manage your data, and then you need to look at, okay, what are the tasks that we perform? Which of these tasks could be automated with agents? What context information will be needed? Will it be, we can see in the future, we'll see things like, this task is performed incredibly often. It requires a lot of data and context. Okay, I might need a fine-tuned model, for example. There's going to be lots of these small different areas. There's a big movement for small models. I was at this Ray conference and I met someone from Salesforce, and they're running a lot of small language models because they've broken down the workflows into small tasks. So I think if you can manage context data, and you're able to deliver that context, and if the models are there's not a huge difference between them, they're somewhat commoditized, then you're going to be competitive. And we're building out some of those companies here in Stockholm, right? We have Legora, we have Tandem Health, we have Lovable, and a few of these others. They're doing the right thing, and that is, I think, key competitive advantage. And big industries need to look at this as well and need to move faster.
Right, enterprise as well.
They have to, because they're going to be under threat.
And just to continue on the point that I just said, the OSS or the open source models and how they will spread out in some ways and forms. And I'm trying to find a positive spin on this, which I think is clearly possible here. Of course, the big AI frontier labs will continue to build these super big models that will be in like GPT 4.5 with 20 trillion parameters. That is, they didn't really improve that much, but and was too expensive to run. They can't really use it.
Was
anyway.
it 20 trillion?
They haven't really published, but the rumor is about 20 trillion. And there will probably be a few of these kind of super big models, but they will not really be used in practice, I would say. Only for very, very specialized use cases, and perhaps for knowledge distillation purposes, meaning that they can be used to build other more specialized open models or on-prem models. That
LLM as judge.
And that actually is, then if that's the case, then if we now let China and US spend insane amount of money on these kind of big models and the infrastructure to train them and also to run them, perhaps we can focus a bit more on running them, perhaps, or just doing the distillation to practical models that is useful for certain countries or companies. Then we don't need to perhaps waste some of the money that they are doing now.
I agree. So Databricks is run by a Swedish guy, Adi Gotzi.
But it's an American company.
They're an American company, we know. But so Databricks bought a company, I don't know if you remember, for $2 billion who were training large language models.
Mosaic,
Mosaic. So they spent $2 billion, and I think maybe a month after they bought them, they were buying the best open source models in the market. So they were going to dominate LLM open source models. Unfortunately, Llama was released by Meta, which just blew it out of the water. And they realized, hang on, can we train large language models? We may be a $100 billion company, but can we be in that business? And they're not.
No.
They don't even care about it. So they're in the business of managing the data infrastructure around that. And I think that is a key infrastructure component we need to build these agentic systems.
But I think also I must say there is a possibility for training, not the pre-training perhaps, right? Not the pre-training of the super big models, but the fine-tuning.
Absolutely, yeah.
For small models that are potentially distilled from big pre-trained models and then adapted to the specific workflows that they need to be run for.
I think it's a journey, right? If I go to an enterprise and I say, okay, you have private data or you have new data.
Yeah.
I think you start with in-context learning and context because it's easy. You can replace a model, and once the infrastructure is in place to manage it. But then when you're in industrialization phase, right, when you need to actually really make money, and the cost of this LLM is a large part of the total cost of delivering the agent, then you go and fine tune, then you optimize the hell out of it and get your costs down. I think, but when you're building, that would be. For me, that would be more like kind of like, hey, I'm going to do MLOps. I'm going to start with experiment tracking, right? Like I'm going to just look at my loss curves until I'm happy. But that's not. You need to build a complete end-to-end ML system first, then optimize it. And I think fine tuning is in the same category. Build your agent, build everything, fine tune then to optimize and to make money. Yeah. So, but it is definitely an important part of it, and I don't think you need the money to do it, right? You don't need the same resources. You just need a few
I think it's
DGX machines or
like,
Spark. You got a Spark one here.
We have a DDX Spark, so
right.
we could. I just got my hands on a DDX Spark, which is cool. I think it's the only one in Europe or something. But I'm going to.
I was
play
shocked
with
how
it.
small it was.
It is, right?
It's insane.
But yeah, that will be fun times. But I think it is a great opportunity, and if we just understood how to use it properly, adapt it for our needs, forget the super big like pre-training, and then focus on adaptation and the applications, and how don't spend or waste time building the infrastructure. Use ready-made systems like Hopsworks. We can actually focus on the value here in Europe.
100%. That's what everyone should be doing.
This should be right. And then, the average European company could actually be much better than the American, and actually the European GDP could actually improve more.
Look, I mean, I'm not, I think the fundamentals are things like, education and...
which we're good at, right?
We were very good. I mean, we don't... I think our universities are in any way inferior to American universities. And obviously there's been a change now in terms of... We're going to get more better quality students maybe from India and China than before. So, capital has been a challenge in Europe, if I'm to be honest.
Yes.
So if you're, a rich kind of person from the Middle East or from Africa or South America, and you're going to invest a certain amount of it in a high risk investment, you probably put in Silicon Valley and not in a European venture capital fund. Yeah. That's something we have a challenge with, I think, but we have enough money in Europe in the aggregate, and it's just not going there. I mean,
Lovable actually turned that negative, as you said, for potentially not the same capital as in San Francisco, to a positive thing, saying for them they probably wouldn't be at all as successful if they would have moved to San Francisco, to the Valley. And the argument was more or less that, of course, one, competition is not as stiff here in Europe, so you get more attention, and you actually also, being a European or Swedish provider has a big value in itself. So given these kind of, the capital is not in the same size, but there are other advantages that actually could be beneficial for European company. So I hope.
Yeah, we're a deep tech company. We have, I think, 11 PhDs, right? And you look in LinkedIn and you see the average time people spend at companies. So we're 7 years old. I think average time is about 4 or 5 years. So if you're building a really deep tech company, imagine you're building rockets like SpaceX. You can't have a turnover of staff leaving every year. Yeah. It's really hard. Yeah. And the same is true of database companies and so on. So that there we have a big advantage here. That people tend to stay in their job and work on the deep tech things for longer. But that's just my experience. I mean, I guess there's other factors at play, but that's helped us a lot. Cool. Definitely.
Jim, so ending up with the standard question that we have here, I think we've asked so many times now, we should write like a research article about this, trying to draw some conclusion for what people think about the future when it comes to AI. And of course we can imagine the two extremes here, either the dystopian kind of Terminator Matrix future where the machines try to kill us all, Or we could end up in a more utopian extreme where we actually have a world of abundance, and we've used AI to solve cancer and fix fusion energy, and we start to move towards some kind of world of abundance where the cost of products and services goes towards zero, and we don't have to work 40 hours a week for every person, etc. And we'll have a better life in some way. Which of these two extremes do you believe in?
So I don't think it's set in stone, right? I think firstly, I think there's agency out there. I think the trend is not good. So from where I'm sitting, the trend is currently an entrenchment of power. And the biggest trend I see, which is not good, is that a lot of the techniques that we've learned in particular in computers, where we align on one or two standards, and then I mentioned it earlier, Uber, but a lot of companies go break things, move fast, and get things done. Yeah. Those principles of how to build computer companies specifically, because people don't do that in other industries. Those principles are applied in politics now in the States. That's crazy when you think about it.
Is it crazy or is it good?
No, it's not good because, well, it's not good because, I think governments have to be accountable above all else. And I think, the rules of business as applied in IT companies, which we tend to kind of just, Peter Thiel said, I'll only invest in a company that's a monopoly. I'm not interested in anything else. Because with a monopoly becomes, you get powers that you otherwise wouldn't have. So I think AI at the moment is, unfortunately, helping entrench some powerful interests in the States that I think are not compatible with European democracy, and that's kind of scary. Yeah. So I do think.
Are we speaking of like the concentration of power that we're seeing?
The concentration of power and the ability to use that power. So the worst thing, of course, is the language that the model speaks. So normal people associate large language models with OpenAI, with Grok, with so on, and ordinary people already understand that Grok speaks a different language to OpenAI. And you pick the model that talks the language you like. And for me, that's not a good trend in terms of aligning people on common shared interests. And if you want to entrench your power, you don't want people to align on common shared interests. You want to do the old British way, where you break them up into smaller groups who then do a bit of infighting, and then you keep your power. So I don't think the trends have been great. But I do think, like I said, I think AI hopefully will commoditize, intelligence will commoditize to some extent, which means we will have an opportunity to use that to make a better society. And that's my hope. And honestly, when I ran the company at the beginning, I was kind of like, yeah, we're building it, it's going to be cool tech and so on. And in the last year or two, I've felt more of a calling that, hang on, we need to build this infrastructure to help us have infrastructures that we can have our own values. If we don't have our own infra, we may not be able to keep our own values and define our own laws and the basic fundamentals of what makes a free society. And if AI is being used to interfere in elections, which has happened this year in Europe, German elections, Romania, and even Britain to some extent, then that's not a good harbinger for what's going to come in the future. Because more and more people are using LLMs to get their information. You see that. Just look at the search trends in Google, and they're dropping off. People are going to do agentic search or agentic chatbot-based search. And if that is all concentrated in the power of a few people who meet for dinner in the White House every other week, that's not scary. Great, right? So I think the future is not set in stone. I hope we can go to, like you said, an age of abundance. That would be, and an age of a better society for everyone.
So, okay, that was a bit negative, but do you think it still will happen? Do you think Europe can
I'm
start
working
to catch
towards
up?
it. That's my job.
You are.
I'm trying to do my bit, and
we're so thankful for that, Jim Dowling, and I hope you continue to do the great work and provide the infra for the rest of Europe so we can actually do that properly, right?
Thanks, Anders. It's been great.
Thank you so much for coming here, and best of luck with the book, and see you soon.
Thanks a million.